Hi, I think it's time to solve the major mysteries of physics. This is the second video of 6 in which I propose 150 solutions for unexplained physical phenomena using just ordinary logic. Now I'll propose a new way of looking at hot and cold. And by doing so, I'll resolve many mysteries in a very simple way, last but not least offering an astonishing simple explanation for the quantum weirdness. That is, that we don't have a clue where subatomic particles are in an atom and in which direction they move. Boyle was the first to presume the existence of an absolute minimum temperature. Kelvin established the absolute zero temperature to be 273 degrees Celsius below zero, that is 0 Kelvin. It is taken for granted that atoms move less at lower temperatures, falling into an ordered grid and somehow stick together by mutual attraction. Now take a look at this. Which spinning top is rotating slowest? The one at the right in front is spinning slowest because it wobbles the most. The slower it goes, the more it moves. The faster a top spins, the less it moves. It seems motionless, though it rotates faster. Now what if it's the same case with atoms at low temperatures? What if at cold temperatures the atoms rotated faster, falling into an ordered grid, and only appeared motionless because they don't wobble? This way at higher temperatures atoms rotate slower and appear more energetic because they wobble more. We need energy to heat matter up but also to cool matter down. So we could distinguish hot energy where atoms rotate slowly and wobble a lot, and cold energy where atoms rotate fast and wobble little. What if near absolute zero atoms were spinning near the speed of light? The speed of light is the ultimate velocity, so atoms can't spin any faster. This would explain the existence of the ultimate lowest temperature, the absolute zero temperature. I have 16 pieces of evidence that all point out that atoms act exactly the same as spinning tops. I'll start with the easiest explanations. Check it out. A liquid turns into a solid state when the temperature drops below its freezing point. It's believed the atoms decrease their movements and therefore they can stay closer together. Water contradicts this supposition. When it turns into ice, it expands. How could motionless atoms need more space? That makes no sense. And if the atoms were staying motionless together, shouldn't they fall apart like loose sand? Wouldn't it be more logical that colder, faster spinning atoms generated a force which keeps them tightened together in a grid specific to the molecular structure? This explains why water expands when it turns into ice. The energetic structure creates more open space between the molecules. Another piece of evidence is the fact that we associate red, little energetic low-frequency light with hot, and blue, energetic light with cold. If the light energy goes up, the wavelength goes down, and the frequency goes up. We don't need no math to understand this. From the color of an object we know what temperature it has. A cold surface emits more energetic high-frequency bluish light, while a hot surface emits less energetic low-frequency reddish light. What we might not realize is that cold molecules emit more energetic high-frequency light. The Meissner effect can be explained presuming only supercold atoms rotate that fast to generate vortexes that trap distant molecules in a fixed or fluctuating position. The same way laser beams can trap molecules in a fixed position. Sebald-Brugmans discovered that some materials even repel a magnetic field at room temperature. These materials must cause crossing ether vortexes that don't line up with magnetic field vortexes. This principle is used for the maglev train, the magnetic levitation train. In the next video I'll describe the ether and its properties. Helium gas becomes liquid only very close to the absolute zero temperature. In the 1930s, it was discovered that supercold fluid helium creeps upwards and goes out of its container. There is no hole in the bottom. The liquid helium creates a film that sticks to all surfaces and therefore it flows even upwards out of its container. So the cold, fast spinning atoms cause vortexes that exceed gravity. And to give more strength to the theory that cold atoms cause strong vortexes, look at this. Oliver Gessner at the Berkeley laboratory has even detected quantum tornadoes in supercold fluid helium. Can there be any more convincing evidence? How could atoms near absolute zero be motionless though create these tornadoes? This is really convincing evidence that atoms rotate faster at colder temperatures. Only very close to absolute zero, liquid helium flows through holes in the bottom that are smaller than the size of a regular helium atom. This is called a superflow. A rapidly spinning top can fall through a smaller hole than one that spins slowly and wobbles a lot. Spinning matter approaching the speed of light is subject to length contraction, making it possible for atoms to pass through holes smaller than their regular size. Kundig experienced a redshift, that is, a length contraction, with a rotating device. I wonder if the makers of this animation knew there was some truth in it. On the atomic level, atoms shrink when rotating near the speed of light.
Oh, Mamma Mia, Santa Maria, Santa Maria.
In the last decade, some well-known laboratories like the Brookhaven lab noticed that atomic clocks tick slightly faster in winter and slow down due to solar flares. In accordance with what I said before, during winter the average temperature is lower, the oscillation of atoms, or better their rotations, accelerate, so atomic clocks start ticking faster. All matter becomes superconductive at extreme cold temperatures, as Heike Kamerlingh-Onnes discovered. A superconductor conducts electric current without any resistance. Electrons don't flow in a wire like water in a tube. Instead, electrons pass over a wire very close to the surface. If molecules would reduce their motion at low temperatures, then why would they conduct electricity more easily? Isn't it more logical that the molecules of a superconductor rotate super fast in a stable grid, passing electrons along the surface? Michael Buckingham discovered that superconductors absorb light with very high frequencies. When an atom is hit by a photon with the same energy level, the photon is absorbed. So logically, colder atoms with higher energy levels absorb photons with a higher frequency. Once more, this proves atoms are more energetic at lower temperatures. Similar to the previous piece of evidence, the Earth's upper atmosphere absorbs cosmic radiation. The absorption of the D layer ceases at night. It absorbs the cosmic radiation with the lowest frequencies. At night the temperature falls. Atoms start rotating faster, so the absorption frequencies increase. And the D layer's absorption of the lowest frequencies don't occur anymore. Lena Howe managed to slow down a beam of light. Light slowed down entering a supercold sodium gas and sped up coming out of it. How could supercold motionless atoms delay light? Isn't it more logical that energetically moving atoms obstruct the light? One can explain this in two ways. Either time sped up and the light virtually needed more time to cross the cold area, or time slowed down and analogically the light slowed down. Like in the arms of galaxies in the previous video, There is an increase or decrease of energy changing the time speed. Examination of the red or blue shift inside the cloud will give a conclusive answer. Likewise, in supercold black molecular clouds, light should be slowed down. I can also add my explanation for the temperature structure of Earth's atmosphere. At the top of the atmosphere, it gets as hot as 1500 degrees Celsius. The friction between supercold high-energetic space ether and atmospheric particles causes heat. Motionless particles can't spontaneously reach 1500 degrees Celsius. I will detail this argument in the next video. Neptune, the farthest and coldest planet in the solar system, has the fastest winds, up to 2400 km an hour. Heat is considered to be the only source of wind. Pretty contradicting, isn't it? Again, it demonstrates cold planetary vortexes easily exceed hot thermal winds. Also see video 4. Sky and marine colors can be explained considering light frequencies are slowed down more in warmer areas. In video 5 I'll explain my new light photon model, being perfectly in line with the fact that cold light is more energetic. The Casimir effect shows that two thin uncharged metal plates hung up vertically in a vacuum chamber a few nanometers apart approach another. Lamoureux built an apparatus actually measuring the force between the plates. He saw the force was stronger with the plate's temperature near absolute zero. My fellow Dutch Hendrik Casimir supposed that virtual particles popped up and disappeared but vibrated more outside the plates and less in between. This should have caused the sheets to approach another. He called it the negative energy force of empty space. But then why would the plates approach another more at extreme cold temperatures? That makes no sense. Following the same logic as the previous pieces of evidence, I say molecules rotate faster at lower temperatures, generating stronger ether vortex strengths. And now, some funny stuff. The quantum weirdness. It's believed strange things happen at the subatomic level. Particles should be capable of being in different places at the same time. Based on this, some believe the same might be the case in the real world, thinking that if elementary particles can be in different places at the same time, we ourselves can be in two places at the same time. Maybe clones of ourselves might be around us in parallel universes, but we can't see them. Theoretical physicists love this stuff. I'll clarify this fantastic misconception. I said clones, not clowns. When we take a picture of a bicycle wheel that spins slowly, we get a sharp image. When it's spinning fast, we get a blurry image. Think of cycling fast when you feel fresh and going slowly when you feel too hot. Similarly, we get a blurry picture of atoms when spinning fast at supercold temperatures, and we get a picture of the atom's inner motions spinning slowly at high temperatures. Particles, like the spokes of the wheel, have a certain position and speed, but it's hard to define where they are when they spin very fast. In order to study subatomic particles, now one cools matter down close to absolute zero, believing atoms hardly move at that temperature. Logically, the Heisenberg uncertainty principle works, because the probability principle works out, only the philosophy behind it doesn't. Atoms, I mean their particles, seem to stop moving close to absolute zero, instead they rotate stably near the speed of light. And therefore it's impossible to determine the position and direction of subatomic particles. All the 16 pieces of evidence I put forward demonstrate I'm telling the cold, hard truth. It might fly in the face of conventional scientific knowledge, reason without persistent preconceptions, and it all makes perfectly sense. We can put aside the intriguing multidimension theories. Classical mechanics and quantum mechanics finally reconcile. This is the end of the weird quantum conundrum. Now I'll put forward some experiments that will also confirm that atoms rotate faster when it's colder. Similar to the Casimir effect, one could execute a temperature experiment in the drop tower in Bremen, Germany, where they can shortly observe loose particles during a free fall. Particles will stick quicker together while making a free fall when the particles are super cold. Also in outer space at weightless conditions, supercold grains will stick together more quickly. It will indicate why dust on the Moon and on Mars sticks so much to spacesuits and exploring instruments. It will also show that planets form more rapidly in cold space than one would expect. In the vacuum of outer space, no atmospheric gas atoms obstruct with the attracting ether vortexes. Multimolecular structures can be analyzed at very low temperatures as the atoms wobble little. Spinning at high velocity, molecules need less space, they can stay closer together in a fixed, stable grid. The atoms appear as spheres because they rotate extremely fast. In order to examine subatomic particles, one can increase the temperature and pressure and generate a strong magnetic field and use laser beams. A magnetic field or laser beams can be used to keep molecules in a fixed position for observation. This way one will finally see the structure and movements inside an atom. But if the magnetic field is too strong or temperatures too high, energy levels of the movements might get imperceptibly weak. Like Lamoureux experienced stronger forces at extreme cold temperatures between two uncharged plates, one can do similar experiments in a vacuum chamber, studying magnetic levitation at supercold temperatures. Without disturbing warm air molecules, the experienced forces will be stronger. The fact that molecules rotate faster when it's colder can also explain other phenomena. Molecular internal string vortexes get stronger at lower temperatures. On Earth, methane gas disintegrates spontaneously in about 300 years. But in Mars' atmosphere, a small amount of methane is found, and there's no source supplying new methane into the atmosphere. One can presume that the colder temperature on Mars strengthens the molecules, preventing methane from decaying. Another alternative explanation. When a steel nut is heated up, the thermal energy of the flame slows down the rotation of the atoms, and the magnetic attraction slowly decreases. Atoms start to wobble more, like slower rotating spinning tops. The magnetic ether vortex strings disconnect. And when the nut cools down by the colder energetic air, it's again attracted. I think I've made you seriously doubt about the preconception that molecules slow down their movements at lower temperatures, considering all the pieces of evidence that follow ordinary logic. Einstein once said, "The only thing that interferes with my learning is my education." Exactly this happens if we keep believing matter moves less at lower temperatures. This theory, we were taught at school, simply doesn't match with all the practical examples I put forward. We are all hypothetical idiots, but in my opinion, my explanation follows ordinary logic. You might ask yourself, if in outer space it's very cold, it should be full of energy, so where does all this energy come from? I'll explain this in the next video. I'll use ordinary logic to reveal the intergalactic dark matter mystery and its distortion of space. I'll enhance our model of the universe, which will make you dizzy. I'll show evidence that there's more outside the universe, and I'll explain the origin of cold vacuum energy and many other mysteries. So, watch my next video. Feel free to subscribe and place comments below. Thanks for watching and see you next time.